There's a hole in the universe about 590 billion kilometers across. Light is the fastest thing there is, and even light would need around 3 weeks just to cross from one edge of it to the other. Set every other black hole you've ever heard of next to this one, and next to it they all look like puddles. The 4 million sun giant at the center of our galaxy. The famous ones in the textbooks. Puddles. It has a name. Phoenix A. And the strangest thing about it is happening right now. After what may have been hundreds of millions of years of silence, it has started to feed again. Over the next 20 minutes, I'll show you what a black hole this size actually is, and you'll watch the words black hole buckle a little under the weight of it. You'll find out why, by every rule we have, it shouldn't exist. You'll see what waking up means for something the size of a small star cluster. And here's a strange one to sit with this early. A black hole this big is so vast that you could drift across its edge, the line nothing returns from, and feel nothing at all as you crossed. And near the end, one idea about Phoenix A that's quietly more disturbing than its size. What it hints about everything else out there in the dark that we have no way of seeing. Stay with me. First, the shape of the problem. A black hole is a place where so much mass is packed into so little room that gravity seals over the top of it, and nothing, light included, can climb back out. For a long time, the textbook kept the whole thing simple. Small black holes, the corpses of dead stars, from a few times the mass of the sun up to maybe 100. Big ones at the centers of galaxies, somewhere between a few 100,000 suns and a few billion. A gap in the middle. Past the big ones, blank space. Our own galaxy's giant is called Sagittarius A star, the dark anchor at the center of the Milky Way. It weighs about 4 million suns. Hold that number, because everything that follows is measured against it. Then, in the early 2000s, the telescopes started turning up black holes that broke the chart. Galaxies that weren't anything special, hiding central giants of 15, 17 billion suns. A quasar more than 10 billion light-years out, weighed at 66 billion. Astronomers reached for a new word, ultramassive. 10 billion suns and up, maybe far higher. And then there was Phoenix. Here's the number the whole video hangs on. By the higher estimates, the event horizon of Phoenix A, the boundary nothing comes back from, runs about 590 billion kilometers across. That's roughly 100 times the distance from the Sun, all the way out to Pluto. You could line our entire solar system up inside it 100 times over. To feel that, you have to know how black holes scale. Mass and size grow together, one for one. Double the mass, you double the radius. Crush our sun down into a black hole, and its event horizon would be only about 6 kilometers across, small enough to lose inside a single city. Sagittarius, A star, 4 million suns, has an event horizon you could tuck comfortably inside the orbit of Mercury. Big, and our solar system would still swallow it whole. Now hold that against Phoenix A, and the giant at the heart of our galaxy looks like a puddle. Every black hole you have ever pictured does. Its boundary alone is a region the size of a small star cluster, and anything that drifts across it, light included, stops existing as far as the rest of the universe is concerned. Put speed against the distance. Light crosses it in about 3 weeks. A passenger jet at cruising altitude would need more than 70,000 years to fly the same line. Numbers at this size stop landing as numbers. Say, 590 billion kilometers, and your mind files it under too big, shrugs, and moves on. That shrug is the real obstacle here. Phoenix A is easy to hear about and almost impossible to actually picture, and the gap between those two things is most of what makes it feel unreal. Now, the discovery, which is a quiet story for something this loud. In 2010, the South Pole Telescope, an instrument built to map the faint afterglow of the Big Bang, caught a smudge in that ancient light, the kind of shadow an enormous amount of hot gas leaves behind. Astronomers swung optical telescopes, X-ray observatories, and radio dishes around to look. What sat there was a swarm of galaxies bound together by gravity around 2 quadrillion suns of total mass, glowing brighter in X-rays than anything of its kind on record. They named it the Phoenix Cluster, and inside its central galaxy was one of the most massive black holes ever found. The size is the easy part of the story. What makes Phoenix A break the rules is how it got here, and what it's doing right now. Start with how it got this big, because that's a question astronomers can't answer with any confidence. The usual way to build a supermassive black hole is slow. Begin with a star-sized one. Let it pull in gas, let it merge with others when galaxies collide, and over billions of years it swells into 1 million or 1 billion suns. The math works, barely. For something like Phoenix A, the math comes apart. There hasn't been enough time. The universe is 13.8 billion years old. To grow a black hole of 100 billion suns by feeding alone, you'd need it eating at almost the maximum rate physics allows, without a single pause, for nearly the entire history of the universe. Real black holes can't keep that up. They choke on their own radiation, throttle their own feeding, take long breaks. Run the numbers honestly, and the clock falls short by billions of years. Phoenix A is sitting at a size the universe simply hasn't been around long enough to grow the patient way. So it either formed in a way we don't understand, or it started out enormous and went up from there. One idea is that its seed was primordial, born straight out of a collapsing gas cloud in the chaos of the early universe, skipping the slow stellar beginning altogether, starting life already tens of thousands of suns heavy. Another is that whole galaxy clusters slammed together early on and funneled several supermassive black holes into the same gravitational pit, where they ground into one impossible thing. Both answers point at the same uncomfortable place. Somewhere in the first stretch of cosmic history, the universe was able to drop a fully formed giant into the dark, and we still can't draw the mechanism on a whiteboard. Phoenix A is the receipt for a shortcut we can't reconstruct. Set it beside our own giant for a second. Sagittarius A star is 4 million suns. Phoenix A may be 25,000 times that. The dark anchor that holds our entire galaxy together would be a rounding error inside it. It helps to see where it lands on the ladder. Ordinary supermassive black holes top out around a few billion suns. Above them sit the ultramassive ones, a galaxy called NGC 1277, once thought to hide something near 17 billion. A distant quasar called TON 618 weighed at 66 billion. Each looked like the far edge of possible the day it was found. Phoenix A may reach 100 billion, sitting at the very top of the heap, in a category with almost no members and no good explanation for any of them. Either way, the textbook is wrong, or at least badly incomplete. By the rules we know, Phoenix A has no business being here. And there it is. Now look at what it's doing. Phoenix A is feeding. Hard. To see why that matters, picture where it lives. A galaxy cluster like Phoenix is flooded with gas. Plasma heated to tens of millions of degrees, glowing in X-rays, filling the space between galaxies across millions of light years. Left alone, that gas cools, the way a hot pan cools on a stove. As it cools, it sinks toward the center, pools there, and collapses into new stars at a staggering rate. That's the prediction. In most clusters, it never happens, and the reason is the black hole. The supermassive giant at the center works like a thermostat. Gas cools and falls inward. The black hole feeds. The feeding fires jets of energy outward. The jets reheat the gas, and the cooling stalls. The loop holds. Stars form at a modest pace. The whole cluster sits in balance. In Phoenix, the thermostat is broken. The cooling is winning. The central galaxy is building new stars at something like 700 to 1,000 suns worth every single year. Our entire Milky Way manages about 1. So picture a single galaxy lighting up new suns close to 1,000 times faster than ours. A place where the night sky is being rewritten on human timescales instead of cosmic ones, soaked in the glow of a baby boom with no clear cause and no clear end. Stand inside a galaxy like that, and the night would never settle. New stars would keep flickering on across the sky, generation after generation arriving on something close to a geological clock rather than a cosmic one. It's a galaxy caught in the middle of its own creation, lit from one edge to the other by the fury of it. And in the middle of all that newborn light sits Phoenix A, swallowing gas as fast as it pours in. Its jets are punching outward, and even they aren't strong enough to choke the inflow off. Phoenix A is an active galactic core in the middle of a feeding event that has been running for tens of millions of years and could run for hundreds of millions more. Whatever it was doing earlier in its life, it is wide awake now. Why it woke up is the open question. The leading guesses point back at the cluster itself. Phoenix is unusually compact for its mass, with most of its matter crammed into a small central region, a steep gravitational funnel that pours gas inward faster than anything can reheat it. And where most giant clusters get shaken up by frequent collisions, Phoenix seems to have gone billions of years without a major one to stir its gas and break the fall. Left undisturbed, the gas settled, cooled, and started to drop. The monster at the center simply couldn't keep pace with the meal. All of that turmoil lights the place up. The gas pouring inward and the energy blasting back out make the Phoenix cluster the brightest X-ray source of its kind ever recorded. A system visible halfway across the universe, precisely because something at its heart has lost its grip on the balance. That's the part that should stop you. Black holes this size are supposed to be asleep. They grew monstrous, ran out of fuel, and went still. The biggest ones are almost always the quietest. Phoenix A is the exception. Phoenix A is awake. Here's where Phoenix A stops behaving like an object. At this scale, crossing the edge would feel like nothing. That sounds wrong. Black holes are supposed to tear you apart. Near a small one, they do. The pull on your feet so badly outmatches the pull on your head that you're stretched into a thread before you ever reach the boundary. There's a word for it: spaghettification. Phoenix A is so vast that right at its edge, the difference in pull across your body would be gentle. You could drift across the event horizon and feel not a single jolt. You wouldn't know you'd crossed it, or that you were already finished. The end would come later, somewhere deep inside, hours or days after you slipped past a line you never saw. Drift closer still, pulled in by gravity and your own curiosity, and the change would creep up on you. The pull would build slowly. The light of the rest of the universe would gather into a small, bright circle behind you. The stars would shift, redden, and crowd into a tightening ring. Then you'd cross a line that no longer let you signal anyone that you'd crossed it. And from the outside, the universe would forget you in an instant. Something like that stops being a predator you can point at. It's closer to a territory, a region of space the size of a small star cluster, fenced off from the rest of reality, where the universe in any meaningful sense simply runs out. At this size, the vocabulary itself starts to fail. The word object suggests something you could circle, measure, stand back from. Phoenix A works better as a place, a domain with a border where crossing in one direction is permanent and crossing back was never on the menu. We don't really have a word for a thing that is also a destination you can never leave. And if you could pull back far enough to take in the whole thing, the central galaxy blazing with the light of hundreds of millions of newborn stars, the plasma around it shimmering in X-rays, jets tearing out from the core at nearly the speed of light and carving cavities the size of small galaxies, the black hole itself would be the one thing you couldn't see. Invisible and unmistakable in everything it was doing to the space around it. But the bigger turn is what Phoenix A is showing us about time. We're watching it from 5.7 billion light-years away. The light reaching our telescopes left before the Earth existed. It traveled while our planet formed and cooled and grew an atmosphere and hosted life and produced creatures who could build the instruments to catch it. And the runaway cooling inside that light, the furious wave of star birth around a feeding giant, is almost exactly what astronomers think happened in the early universe, back when the first supermassive black holes were assembling. We thought that era was finished. Phoenix A is a live replay of it, billions of years deep in the past, still arriving at our doorstep. Think about what that means. For decades, we filed the wild runaway assembly of the first giant black holes under deep past, finished long before any telescope could catch it in the act. Phoenix A hands us a working copy, late and far away, but unfolding in real footage. An ancient process caught mid-stride. Then comes the colder thought. Phoenix A is awake. And its kind, the ultramassive giants, are usually anything but. They grew monstrous, drank their galaxies dry, and went dark. We found this one for a lucky reason. Its cluster happens to be cooling out of control, which lights the whole system up in X-rays. The black hole gives off nothing we can catch on its own. So here's the question that lingers. And it isn't really about Phoenix A at all. How many others are out there, fed, finished, and silent, with no accident of the neighborhood to give them away? The loud one is the accident. The quiet ones are the rule. So what do we do with Phoenix A? Mostly, it resets the scale in your head, and that has happened to us before. For most of human history, the biggest things people could imagine were the things they could see. Mountains, oceans, the horizon. Then the Earth turned out to be a sphere drifting in space. Then the Sun turned out to be 100 times wider than the Earth. Then the galaxy turned out to hold hundreds of billions of stars, and the universe hundreds of billions of galaxies. Every step outward made us smaller and turned whatever we'd just called enormous into a footnote. Phoenix A is the next footnote. A black hole so large the word barely covers it. A boundary that light needs weeks to cross. A weight heavy enough to hold an entire galaxy cluster together. And it may not even be the ceiling. Some theorists pencil in a class above it. Stupendously large black holes. Objects so big they press against the limits of what general relativity will allow. Nobody knows how many exist, or how they formed, or what part they play in the long fate of the galaxies built around them. What we do know is that Phoenix A is one of them, and it has spent the last few billion years quietly proving that the universe runs hotter and stranger and bigger than the textbooks ever let on. Here's the part that stays with me. Forget the size for a moment and forget the math. What gets me is the patience. Somewhere out there, 5.7 billion light-years from the chair you're sitting in, a hole in the universe is open. It opened long before the Earth formed. It will still be open long after the Earth is gone. In the time it took its light to reach us, every breath you've ever taken came and went. And Phoenix A simply kept doing what it has always done. Something that enormous can afford to wait. It can sit through the rise and fall of entire civilizations, outlast suns and worlds and species, and still be hungry at the end of it. The loud things in the universe are easy to be afraid of. The one that should unsettle you is the thing that's been waiting in the dark, in no hurry at all. If that landed, the next one will too. There's an object out there stranger still, the one that bends the rules harder than anything else we've met. And that's where we're going next. Subscribe so it finds you. The universe only gets stranger from here. It always does.